Welcome to The Explainer. Have you ever wondered what's really going on inside a data science interviewer's head? Well, today, we're going to pull back that curtain. We'll walk through some of the toughest questions so you can show them not just what you know, but how you think. All right, so picture this. You're in the hot seat. The interviewer, they're not just looking for a coder. Nope, they're hunting for a real problem solver, someone who gets the why behind the what. They need to know you have a rock-solid grasp of the statistical ideas that are, the foundation of all data science. And then things get real. The interviewer leans in and says something like, okay, we need to forecast our demand for the next quarter. Here's the data. How would you tackle that? See, this isn't just about your technical chops. It's a test of your whole problem-solving mindset. So your first big challenge is a classic application question. We're talking about a time series forecasting problem. This is exactly where you get to bridge the gap between pure theory and a real-world business need. They slide this chart over to you. At first glance, it seems simple enough, right? Monthly water demand. But if you look closer, you can spot a definite trend. This isn't just some random noise. It's a textbook example of what we call a non-stationary time series. And trust me, this is a super common and tricky problem you see all the time in the real world. Okay, now here's your chance to really shine. Instead of kind of stumbling around for an answer, you can confidently bring up the ARIMA model. You just explain that it's a super powerful tool for this exact type of problem. And the whole goal is to find what's called a parsimonious model, which is just a fancy way of saying the simplest model that actually works and gets the job done. And you don't just drop a buzzword and leave it at that. No, you lay out a clear, step-by-step plan. You say you'd use the Box-Jenkins methodology, this 5-step process you see here, and you'd kick things off with the most critical step of all. Step 1, the stationary check. Now, any good interviewer isn't just going to take your plan at face value. They're going to push you on the why. This is what we call the deeper dive question. It's designed to see if you really understand the core principles behind the methods you're choosing. And then comes the follow-up. Ah, yes. This is the question that really separates the beginners from the experts. They're not just asking what you do, they're asking why you do it. They're trying to figure out if you're just, following some recipe, or if you genuinely get the theory behind the model. So you can confidently explain that the single most important assumption for an ARIMA model is something called stationarity. Here's a way to think about it. If you were trying to predict the weather, you'd want data from a place with a pretty stable climate, right? Not somewhere with insane temperature swings. Well, stationarity is basically that stable climate, but for your data. And this slide right here shows that concept perfectly. See on the left? That's our original data with that obvious upward trend. But then, look at the right. After we apply a pretty simple technique called first differencing, poof, the trend is gone. Now the data is stationary, and it's ready for us to model. See, by getting rid of that predictable trend, you're basically letting the model ignore the noise and focus on the more subtle, interesting patterns underneath. And that is the secret to building a really accurate forecast. Okay, so you've absolutely nailed the application question. But now the interviewer is going to want to see if you have the theory to back it up. So they're going to pivot to what we call a foundational question, just to test how wide and deep your knowledge really is. And they might throw you a total curveball, something that seems like it's coming out of left field. But it's not random, I promise. This type of question is all about checking if you've really mastered the fundamental building blocks of stats and probability, the stuff that all of data science is built on. So you just calmly explain that the exponential distribution is all about modeling the time between events. Like how long you wait between customers arriving at a store or the time between calls at a call center. The really important part is that these events are independent and they happen at a steady, constant average rate. But here's the real kicker. The most unique and honestly the most powerful property of this distribution is that it's memoryless. So what on earth does memoryless even mean? Well, imagine you're waiting for a bus, and it usually comes about every 10 minutes. If you've already been waiting for 5 minutes, you'd think, okay, it's got to be coming soon, right? But if the bus arrivals follow an exponential distribution, that's actually not true. The chance of the bus showing up in the next minute is exactly the same whether you've been waiting for 5 minutes or just 5 seconds. The past just doesn't matter. It's like the clock resets every single second. So at this point, you've shown you've got the technical skills and you know the theory. But a truly great data scientist is more than just a technician, right? So for this last part, the interviewer wants to see if you can think like a real scientist. if you can connect all the dots between the data, the model, and what it all means for the real world. They might ask you about the trade-offs between different kinds of statistical tests. Think of it this way. A parametric test is like a specialized, high-powered tool. It's amazing for one specific job, but only if all the conditions are perfect. A non-parametric test, on the other hand, is more like a Swiss Army knife. It might not be the most powerful tool for any single task, but it's super flexible and works in all sorts of situations. A great data scientist knows exactly which tool to pull out of the toolbox and when. And you want to make it super clear that your job doesn't just stop once the model is built. A great data scientist is also a responsible one. And that means you're rigorously testing your model, you're actively hunting for and dealing with any statistical bias, and you're super careful about which variables you choose. The goal is to build a model that isn't just accurate, but also really robust and reliable. So by connecting all these dots, from application to theory to that big picture thinking, you've shown that you're not just some data cruncher. You're a true data scientist. You're the kind of person who can not only build a model, but who also gets its limitations, understands its real-world impact, and can use it to actually make a difference. So next time you walk into that interview, just remember, it's not just about what you know, it's about showing them how you think.